Hi folks, welcome to another great video on AI Masterclass. This is part 1 of a 5-video series that will finally make AI make sense. In this episode, you'll see what actually lives inside systems like ChatGPT, image generators, Claude, and scientific AIs like AlphaFold, the neural network, a kind of digital brain that learns patterns. By the end of this video, you'll be able to explain a neural network using one simple example, how it tells cats from dogs. And once you get this, everything else about AI becomes much easier to understand. What is a neural network? Every modern AI you hear about today uses some form of neural network. A neural network is just layers of tiny calculation units called nodes connected by links. You can think of it as loosely inspired by the human brain. In your brain, you have billions of biological neurons connected by synapses. In an artificial neural network, you have nodes connected by weights, but the idea is similar. Lots of simple units working together to spot patterns in data. The cat versus dog example. Let's make this concrete. Imagine a neural network trained to tell cats from dogs. You feed in a cat photo. The image gets turned into numbers, pixel values, and those numbers are pushed into the input layer of the network. As the data moves into the input layer, each node receives a tiny piece of that information. From there, it passes the processed signal onto the next layer, and then the next, and the next, all the way through the network. As those numbers move through each layer, different nodes activate in different ways. At the very end, the output layer might say something like cat 95, dog 5. That means the network is about 95% confident this image is a cat. That 0.95 isn't magic. It's the result of millions of tiny weighted calculations stacked together, all tuned to recognize what catness looks like compared to dogness. Now give the same network a dog photo. The same process happens. Image to numbers, numbers through layers, nodes activating, and finally an output like cat 2%, dog 98%. Same network, same process, different input, different output. Neural layers are like knobs that could be tightened when training the model. Imagine each connection between nodes is like a tiny knob or dial that controls how strongly one node influences the next. For one image, certain paths through the network light up strongly, maybe shapes that look like cat ears. For another image, different paths light up, maybe shapes that look more like a dog's muzzle or body. In a biological neuron, signals usually follow an all or none rule. The neuron either fires or it doesn't once it crosses a threshold. In an artificial neuron, the activation can be partial. A connection might pass through 30% of the signal, or 70%, or 100%, depending on its weight and activation function. That flexibility is what allows the network to represent very subtle patterns. By tuning millions of these tiny knobs, the system learns to carve out a boundary between cat and dog in a very high-dimensional space. Layers, and why it's called deep learning. Now let's talk about layers. The very first layer is the input layer. That's where the raw data, like pixel values, enters the network. The very last layer is the output layer. That's where you get your prediction, like cat or dog, with a probability. All the layers in between are called hidden layers because you don't directly see them from the outside. They're where the real feature extraction happens. When you hear the phrase deep learning, it simply means using neural networks with many hidden layers. Early layers might detect very simple features like edges or small textures. Deeper layers can detect more complex structures like eyes, paws, or even the overall shape of an animal. Stack enough layers together, and the network can learn extremely rich patterns from raw data. That's why deep learning has been so powerful for images, language, audio, and even protein structures. What's next? How does it get good? So far, you've seen what a neural network is and how it turns an image into a cat or dog probability. But we've skipped the biggest question. How does it become good at this in the first place? In the next video, we'll walk through how AI actually learns. Data, labels, loss, gradient descent. If you want to truly understand AI, you definitely don't want to miss part 2. Right now, you understand the engine inside modern AI. Layered nodes, weighted connections, and outputs that look like probabilities. In part 2, you'll see how that engine is trained step by step until it goes from random guesses to surprisingly intelligent behavior. If this helped you finally see what a neural network is, make sure you watch part 2 next. Thank you for watching the video. I'm sure you got value from it. Please like and subscribe for such content. Hope to see you in another great video. Till then, have fun and take good care of yourself and your loved ones.